Welcome you all to the video lecture on signals in system. Today we are going to find out the Laplace transform of few signals. First of all, we need to know the Laplace transform formula. The Laplace transform formula is given by L of x of t is nothing but capital X of s, which is given by minus infinity to infinity x of t e power minus st dt. So this is a Laplace transform formula. So here in the first problem, our x of t is nothing but u of t. So we need to know what is u of t. U of t is nothing but step signal, and the definition for step signal is it is 1 for t greater than or equal to 0 and it is 0 for t less than 0. That is, u of t is nothing but 1 and it exists from 0 to infinity. So using this, I can rewrite this integration as, that is, Laplace of u of t. So generally I can write it as x of s, but the limit ranges from 0 to infinity. Why? Because my u of t exists only from 0 to infinity. For other values it is 0. So 0 into any value is nothing but a 0. So we are removing the negative values of t. Only we are considering the t values from 0 to infinity, because only for that duration the amplitude of u of t is 1. So here x of t value is nothing but u of t. So if you want, you can write as it is u of t e power minus st dt. In the next step we can rewrite. So for 0 to infinity, what is the value of u of t? U of t value is 1. So I can replace u of t as 1, e power minus st dt. So we can now apply the integration. So 1 into any value is that particular value. So it is nothing but 0 to infinity e power minus st dt. So the integration of this is nothing but e power minus st divided by the t's coefficient. T's coefficient is nothing but minus s. So apply your limits. While applying the upper limits, that is, we have to replace t by infinity. So e power minus s into infinity divided by minus s. While applying the lower limit, we need to introduce one minus. Already here one minus is there. Minus into minus will become plus. So e power minus s, again t value, lower limit to t value is nothing but 0. So here it is plus s. Why? Because minus into minus it already becomes s, plus s. So now we can write like this. And again infinity into any value is infinity. So e power minus infinity is 0. And 0 into any value is 0. So e power minus s into 0 is nothing but e power minus 0. It is nothing but 1. E power 0 or e power minus 0, it is nothing but 1. So this value completely it becomes 0, and this particular value it becomes 1. So I can write left hand side, that is x of s, which is nothing but Laplace transform of u of t, as first term becomes 0, second term numerator I have 1, denominator I have s. So Laplace transform of unit step signal u of t is nothing but 1 by s. Okay, so this is the important formula where this can be used in inverse Laplace transformation. So you have to remember the formula. The Laplace transform of u of t is nothing but 1 by s. So now let us apply Laplace transform for the shifted step signal. So the same concept we can use. Now for the second problem, we have Laplace of x of t, that is nothing but here Laplace of u of t minus 2. So u of t minus 2. For this we need to find out the Laplace transformation. So before applying the Laplace transformation, again we need to know what is u of t minus 2. So we know that u of t is equal to 1 for t greater than or equal to 0 and 0 for t less than 0, and this is the plot for u of t. So using this plot we need to find out what is u of t minus 2. It is time shifting operation. For time shifting operation we need to substitute t minus 2 equal to 0. So t becomes 2. So this 2 we need to add with each and every instance of t in u of t. So 0 plus 2 will become 2, infinity plus 2 will become infinity. So the signal gets shifted from 0 to infinity as 2 to infinity. This is for u of t minus 2. Okay. So I can simply write u of t minus 2 is nothing but 1 for 2 to infinity. Okay. So now the range has been changed from 0 to infinity as 2 to infinity. Okay. So for this signal, again the general formula for Laplace transformation is what? Minus infinity to infinity x of t e power minus st dt. So we can write this as 2 to infinity. 2 to infinity. What is x of t value? X of t is nothing but u of t minus 2 e power minus st dt. So again I know that u of t minus 2 is nothing but 1. So 2 to infinity 1 into e power minus st dt, and integrate this. Anyway 1 into any value is nothing but that particular value. So 2 to infinity e power minus st dt. Integrate this e power minus st divided by minus s and apply your limits. Apply your upper limit e power minus s. Wherever you have t, replace it by infinity. For applying your lower limit, we need to introduce minus. So minus into minus will become plus e power minus s into 2 divided by s. So as that of the previous problem, e power minus infinity is 0. So this term becomes 0. Only this value exists. So I can write Laplace of u of t minus 2 as e power minus 2s by s. Okay, e power minus 2s by s. So we have one more subdivision formula, subdivision problem, u of t plus 4. So for u of t plus 4, we need to find out the Laplace transformation. Again the same concept. First draw unit step signal. The value is 1 for 0 to infinity. If we need to find out u of t plus 4, equate t plus 4 to 0. So t is equal to minus 4. Add this minus 4 with each and every instance of t. So 0 will become minus 4. Infinity minus 4, again it is infinity. So this signal has been shifted like this. Okay, the amplitude remains same, it is 1. So this is nothing but u of t plus 4. This is a time shifting operation. So equate t plus 4 equal to 0, find out the t value, add t value with each and every instance of u of t, so that you can find out u of t plus 4. So in simple I can write u of t plus 4, the value is 1 and it exists from minus 4 to infinity. Okay. So as usual we need to write the Laplace transformation formula. The general formula is Laplace of x of t is equal to minus infinity to infinity x of t e power minus st dt. Now the limit has been changed as minus 4 to infinity, and x of t is nothing but u of t plus 4 e power minus st dt. And for minus 4 to infinity, this value is nothing but 1. So 1 into e power minus st dt. Again it is minus 4 to infinity e power minus st dt. Apply the integration. So e power minus st by the t's coefficient minus s. So you can write the equation as this. Apply the upper limits. So e power minus s into infinity divided by minus s. Apply the lower limits. Minus into minus will become plus e power minus s into minus 4 divided by plus s. Okay. So again we know that e power minus infinity is equal to 0. So this terms become 0. Only the second term exists. It is given by e power 4s divided by s. So I can write that Laplace of u of t plus 4 is nothing but e power 4s divided by s. Okay. So from these three problems, okay, the important thing here, from these three problems, we can conclude that Laplace transformation of u of t is 1 by s. Laplace transform of u of t minus 2 is e power minus 2s by s. Laplace transform of u of t plus 4 is e power 4s by s. So from these two things we can conclude that Laplace transform of u of t minus a in general is nothing but e power minus as by s, and Laplace transform of u of t plus a is nothing but e power plus as by s. Okay. So this is the important formula which you should remember. Laplace transform of t minus a is nothing but e power minus as by s. Laplace transform of u of t plus a is e power as by s. Okay. Thank you. Thanks for watching.